All right, let's dive right in. Today, we are going on a fascinating journey. We're going to follow a single pain signal right from the moment it happens and trace its incredible path all the way up into the command center of your brain.
So here's our game plan. We're going to start with the absolute basics. What exactly is pain? Then we'll zoom in on the facial nerves, a real superhighway of sensation. From there, we'll head into the brain to see how it processes all this information. Then we'll look at some hidden factors that can change how pain feels, and finally, we'll tie it all together with stress and sleep.
Okay, first up, what is pain? I mean, we all know what it feels like, of course, but what's actually happening on a neurological level? Let's break down that very first sensation.
I mean, really think about it for a second. That quick, sharp sting from a paper cut feels like it's from a completely different universe than, say, the slow, throbbing pain of a headache. So why is that? It's not just your imagination. Well, it kind of is. But the story starts way before it gets to your brain. It all comes down to the body's wiring. See, you've got two main types of data cables. First, there are the A delta fibers. You can think of these as super fast fiber optic cables. They have this fatty insulation called myelin, which lets them transmit that sharp, shooting pain signal almost instantly. But then you have the C fibers. These are more like an old, slow dial-up connection. They don't have that insulation, and that's why they carry that delayed, dull, throbbing kind of ache. And here's where it gets really cool. It's about what these different fibers are designed to detect. Your fast A delta fibers are specialists. They're really only looking for physical pressure or big changes in temperature. But the slow C fibers? They're the generalists. The term is polymodal, which is just a fancy way of saying they react to pretty much everything. Pressure, heat, and even the chemical soup that your body creates with inflammation. And that's a big reason why some pain just lingers and throbs. Okay, so we've got our signals. They've been generated. Now where do they go? Well, let's move to a very specific and very busy network, the superhighway that handles all the sensation in your face, which is run by the trigeminal nerve. Now, before we meet the star of this section, we need to get one key concept down, the dermatome. Your nervous system has basically created this perfect, detailed map of your entire body. A dermatome is just one little patch of skin on that map that reports back to a single nerve. It's an incredibly organized system. And when it comes to the face, the trigeminal nerve is the undisputed king. It is the main channel for pretty much everything you feel in your face and mouth. We're talking touch, temperature, and yup, pain. Its territory is just huge. And this map here shows you its domain perfectly. The nerve is split into three main branches. The first one, V1, covers the top third of your face, your forehead, scalp, upper eyelid. Then V2 takes the middle section, your cheek, your upper lip, and all your top teeth. And finally, V3 covers the lower jaw area, which includes your lower lip, your bottom teeth, and even your tongue. So yeah, from a tiny toothache to a massive headache, this nerve is almost always involved. All right, the signal has traveled down this superhighway, and now it's arriving at its destination, the brain's central command. This is the critical step where a raw electrical impulse starts to become the actual experience that we call pain. And here's where things can get a little weird. Let me ask you this. How is it possible that a problem in your neck can actually cause a headache? A lot of people experience this. It feels like the wires are crossed, right? But there's a very clear neurological reason for it. The answer is something called convergence theory. Now, the easiest way to picture this is to imagine two small country roads, one coming from your neck and one from your head. Before they reach the city, which is your brain, they merge into a single highway. All your brain knows is that there's traffic coming down that one highway. It can get confused about which of the two little country roads it actually came from. So let's just walk through it. You've got signals coming from your neck, the cervical nerves, and signals from your head, the trigeminal nerve. They both arrive and plug into the same relay station, the same neuron in your brainstem. They converge. And because your brain deals with signals from your head all day long, it just kind of defaults to that explanation. So you feel a headache, even when the real issue is down in your neck.
And this critical convergence point, this central hub, has a name. It's the subnucleus caudalis, and it's located in your brainstem. Think of it as the main arrivals terminal for any and all pain information coming from your face and mouth. It's the gatekeeper. But here's the wild part. Even after the signal passes through this hub, it's not pain as we know it. Not yet. It's just raw data. The journey's final, most important stop is the thalamus.
The thalamus is like the brain's executive suite, where this data is finally presented to your consciousness. This is the exact moment a signal becomes a feeling. It's the moment you become aware of the pain.
But the story doesn't end there. The intensity of your pain, what it feels like, that's not just decided by this one simple pathway. There's this whole other network of hidden influencers that can act like a volume dial, turning your pain up or down.
First up is the autonomic nervous system. This is your body's automatic control panel. It's got two really famous divisions. You've got the sympathetic system, which is your fight or flight response that gets you all revved up. And then you have the parasympathetic system, your rest and digest response that calms you down. And this whole system is deeply connected to how we experience pain.
And here is a really powerful real-world example of what happens when that system gets disrupted. Horner syndrome happens when there's an injury to those sympathetic nerves in the neck. And you can see the results right on someone's face. Their pupil constricts, they stop sweating on that side, their face gets flushed, and their eyelid droops. It just goes to show how much control these background systems really have. Okay, another huge influencer is your immune system. It actually talks to your nervous system using these little chemical messengers called cytokines. When you're sick or you get injured, your immune system just floods the area with these things. And while they're there to help, they also act like a giant amplifier for your nerves, making them way more sensitive and cranking the volume on pain. It's the main reason you feel so achy all over when you have the flu. So for our last section, let's zoom all the way out. Let's connect all this neuroscience to two of the biggest forces in our daily lives, stress and sleep.
When you experience stress, your body kicks off this chain of command called the HPA axis. It's basically a cascade. The hypothalamus in your brain sends a signal to your pituitary gland. That gland then sends a signal to your adrenal glands. And the very last step is the release of that famous stress hormone, cortisol.
Now, in short bursts, cortisol is amazing. It gives you the energy you need to deal with a threat. But the problem is, when stress becomes chronic, that system never really shuts off. You get a constant flood of cortisol, and that can be really destructive. It can start breaking down healthy tissue like muscle and bone, and it can even damage the parts of your brain that deal with memory. It also just keeps your whole system on high alert, which can make pain feel so much worse.
So what's the antidote? Well, one of the most powerful ones we have is sleep. Research is showing again and again that proper sleep, cycling through those deep NREM and REM stages, is absolutely essential for restoring the brain's own natural pain-fighting systems. Sleep is literally when your body and brain do their nightly maintenance, refilling the tanks of the very neurochemicals that help you control pain signals.
And that leaves us with one last big thought to chew on. We've seen the whole intricate journey of a pain signal. We know that stress can amplify it and that sleep can suppress it. So the question becomes, if sleep is one of the most powerful, built-in painkillers we have, what is the true cost of a modern lifestyle that so often asks us to give it up?